Okay, as you are aware, we are about a week behind on our scheduled calendar. So what I wanted to do is I wanted to introduce to you the next topic, which is called implicit differentiation, before the Thanksgiving break, so that when we come back from the Thanksgiving break, we can go ahead and move on into our next topic, which will be related rates, and that will actually set us on schedule for the next 6 weeks. Now, I will be honest with you, probably during the Thanksgiving break, I will give you, before you leave for the break, a take-home quiz, because you do have a quiz scheduled for this topic. Now, remember that most of my quizzes are about 5 to 6 questions long, so it won't be a huge assignment for you to complete for the week. Even if you do one problem a day, that's Monday, Tuesday, Wednesday, Thursday, and Friday, you should be set for it, and that should be an easy 100 for you for the beginning of the next 6 weeks. So let's go ahead and start off with our next slide. Now I have made copies for you, so if you just want to follow along with me, you can do that. Okay, it says, how would you find the derivative in the equation x squared minus 2y cubed plus 4y equals 2, where it is very difficult to express y as a function of x? Now, up to this point, most functions have been expressed in explicit form. What is explicit form? Well, let's go back to the previous test that you've taken. Every time that I've asked or I've given instructions on a test or a quiz, I've always said, find the derivative, and I've always given you the problems as y equals. It's always been solved for y. That is explicit form. The variable y is explicitly written as a function of x. Okay, however, some functions are not written as a function of x, especially this example that's given to you. Now, if you try to solve it as a function of x, that means you have to do a whole bunch of algebra, and usually when y'all have to do a whole bunch of algebra, you tend to kind of lose track of the problem or the function and end up usually making an error with your algebra. So this is where the topic or the process of implicit differentiation is introduced to you. And what this basically means is that when we differentiate terms involving x alone, we can differentiate as usual because we're differentiating with respect to x. But when we differentiate terms involving y, we must apply the chain rule or any of the other rules that we've learned. Now, keep in mind, I don't know if I've told you, but basically differentiation is just a fancy word for derivative. So if I haven't told you that, make sure you are aware of that. Okay, so let's go ahead and look at some examples of implicit differentiation. And let's start off with something simple. Okay, so let's differentiate the following with respect to x. Okay, so the first one is 3x squared. Now that one is simple. If I would have given you something like y equals 3x squared, take the derivative of that. We all know that is the chain rule or power rule, however you want to call it. And basically that will give us 6x, correct? Great. I hope everyone got that. Okay, so now let's take a look at the next one. It says 2y cubed. But what do the instructions say? It says differentiate the following with respect to x. So in other words, you do not know what y is. So let's go ahead and apply the chain rule just like the definition says. So we're going to keep the constant, which is 2. We're going to bring the power to the front, so we're going to bring 3 to the front or right behind 2. Now we're going to have y to the 1 less power. So what is 1 less power of cubed? It's squared, correct. Now the chain rule says that we have to take the derivative of what's being raised to the power. Well, we can't take the derivative as usual because first of all, that is not an x, correct? So when we can't take normally the derivative of that variable, all we do is say, okay, well, since we can't take the derivative of it, we just basically write what the derivative of that would be, which would simply be y prime, just like that. And this is what implicit differentiation is all about. Okay, so all in all, our answer would be 6y squared y prime. Okay, let's take a look at the next one. It says x plus 3y. Okay, we can actually do the first one. We all know that derivative of x, if you do the power rule, you're going to end up with just 1. Great, we got that part. But now, the next part, if we would have taken the derivative of 3y, that would give us 3y prime. Pretend that we're an x right there. 3x, the derivative of 3x is 3. Well, now since it's not the x variable, it's the y variable, all we do basically is the derivative of 3y is 3, but now we got to attach what the derivative of y would be, which in this case would be y prime. Now with these, it might be better for you to either leave them as y primes, or if you remember correctly, y prime is the same thing as saying dy dx. So you can see it as that, or you can see it as the form of the fraction part. Okay, so now we have xy squared. And first of all, what are those two variables doing with one another? They're being multiplied with each other, correct. Now, that should give us an automatic clue of what rule we need to use, or what derivative rule we need to use. And what is that? The product rule, correct. So if we apply the product rule, we're going to have the derivative of the first. Well, what's the derivative of x? Simple, that's 1. Times the second, which is y squared, correct. Now we take the first, which is x, times the derivative of the second. Well, that's where we do implicit differentiation. We say the power, which is 2 to the front, times the expression to the one less power, which is to the power of 1, times the derivative of what's being raised to the power, which is y prime. Now keep in mind that this is written backwards for you, but it's the exact same thing. We have the first part, which was this part right here, so let me go over it again. The derivative of the first, the derivative of x is 1, times the second, which is y squared, plus the first, which is x, times the derivative of the second, which is 2y, y prime. So as you can see, if we combine everything, if you want to clean it up, basically it would be 2xy, y prime, plus y squared. Okay? So it's basically just doing the exact same thing, but now we are given the equation in implicit form. Okay, so let's take a look at this next one. It is find dy dx given that y cubed plus y squared minus 5y minus x squared equals -4. So in this case, we need to, one more time, introduce implicit differentiation. So let's go ahead and basically derive or take the derivative of each term. Now keep in mind here that each term here is not being multiplied or divided by anything. So this is basically, we take each term, take the derivative of it. It's simple. So let's take the derivative of the first. We have to do the chain rule. So we say the power, which is 3, times your expression to the one less power, which is y squared, times the derivative of what's being raised to the power, which would be y prime. So that would be our first term. And in this case, y prime is written in the fraction form dy dx. Now we say plus, and we do the power rule one more time. The power, which is 2, times my expression to the one less power, which is to the power of 1, times the derivative of what's being raised to the power, which is dy dx, minus 5 times the derivative of what's being raised to the power, which would be dy dx. Now keep in mind that when you see something like this, so in other words, remember that I told you that if you always have x to the first power, when you take the derivative of that, you can do the product rule because let's say 7x. If you say derivative of 7x, that equals to 7. And I've told you before, you can do the product rule. Yes, you can. But the first term is probably going to go to 0 because when you take the derivative of that constant, which is 7, it'll be 0. leaving you with only the second term, which will basically leave you with just 7. So if you take the derivative of 7x, you're left with 7. In this case, when you're doing implicit differentiation, when you take the derivative of something to the first power, you keep the constant and just add the implicit form of the variable, so dy dx. Minus, now this case is already in variable, or with the x variable, so you just keep it, and it's negative 2x equals, now we all know that a derivative of a constant is 0. Okay, so our main method here is to actually get dy dx by itself. So what we need to do here is either move some things around and collect like terms so that we can get our equation equal to be equal to dy dx. So in this case, let's go ahead and isolate the dy dx's. So in this case, we are going to move the 2x here to the other side. Now when I move this negative 2x to the other side, it becomes a positive 2x. Now on the left hand side, all I have are my variables that also have the dy dx. Now if all three of these terms have a dy dx in common, then what can I do? I can factor it out. So I'm going to factor a dy dx. When I factor out a dy dx, I'm left with 3y squared plus 2y minus 5. Now my next step is to basically just get dy dx by itself. Well, what are these two terms doing? This dy dx, what is it doing with everything inside the parentheses? Basically, they're being multiplied by each other, correct? So in order for me to get dy dx alone, what would I need to do? I would need to divide everything by 3y squared plus 2y minus 5. And what I do to one side, I must do to the other. So when I solve for dy dx, I get 2x over 3y squared plus 2y minus 5. This is implicit differentiation. Is not as hard as most want to make it seem as. It only gets hard when we get to the word problems, which will be after Thanksgiving break, called related rates. Okay, so in this case, what I want to do, I think I want to go ahead and stop here with going over examples with you. And let me see. I would like for, since we have 9 students in here, I would like for y'all to go ahead and turn to page 146. And let's go ahead and do 1 through 9 today, just for practice, 1 through 9. I would like for number 1 to be done by Justin, number 2 to be done by New, number 3 Celeste, number 4 Elijah, number 5 Denise, number 6 Frankie, number 7 Chelsea, number 8 Sterling, and number 9 Kim. Okay, so go ahead and finish those up, and then I would like for them to be written up on the dry erase board, and make sure that you write on there, do not erase. I should be back at the end of the day if I'm not back, but just make sure you write do not erase on the board so that the custodian will not erase the problems, and I will check them for tomorrow morning, and we will go ahead and start the movie tomorrow. Okay, thank you.